the relationship between what's going on here and what's been said so far, at least in a few cases. So let's go. We don't want to take the generals out of the equation when we're building robots, by the way, in terms of robots and ethics and Terminator, because that's where the money comes from, at least in my case. So we don't want to do that. Okay. And this work in particular is supported by IBM more than the other sponsors. So the need for formalization. This happened, and you know about it, but we really don't know what happened in light of two things. Now, people have said they're not in favor of formalizing things. There's no other way to do decent engineering other than by formalizing things. So I don't know this notion that we don't have to formalize things, we're just going to go our merry way. But it's never worked, and it will never work. Here are two questions. We don't know what Watson is, or at least we didn't know what it is. And we have no idea how to evaluate a QA system. Presumably that would be part of any generally intelligent entity, the ability to answer questions. This one is taken care of. If you're interested, it took Naveen and I a long time to write the paper, and it's fairly long. But we claim to be the only, well, no, there's Dave Farici, but 3 people on the planet who understand top to bottom, logico-mathematically speaking, what Watson is. And then we have this one, which is what the paper and the proceedings is about, ostensibly what this presentation is about. So there are reasons for doing the formalization. I probably don't have to go through that. We have sort of a high-level notion of what's required. You have to have a set of questions, you have to have a set of answers, a corpus, and other artifacts, and then this definition appears in the proceedings, and then we march on from there to talk about some dimensions. We don't have a single theorem in the paper, by the way. So this is really just a foundation. We do have, finally, a few theorems, but they're really boring. I think I have a couple on the slide there. Now, these are the dimensions that arise from the formalization. I want to get to the one that I think is somewhat relevant to things that have happened to today. Dimension 1 takes account of time. So we talk about a need to have a time index and then see sort of where it is in a world line given the question. I'm going to just, I'll give you the example that's up there. Probably the world's best QA technology is at Bloomberg, by the way, in New York City. IBM may be upset that I said that, but here's a dynamic question versus a static question. The questions in the Jeopardy competition were all static. That was all based on frozen data. It was based on data that was very small. By the way, it wasn't big data. It was small data that was all hand-curated using UEMA, and there was no real-time access to the web. But these kind of questions weren't in the game. So these are some of the parameters that you could have in a question along the first dimension where time is a factor in what Naveen calls dynamicity. Now, dimension 2 is world knowledge. And this has been historically important to AI. This morning I suffered through talks where such phrases as the expert system stuff didn't work, and I think Doug Lennett's view of AI or vision for AI didn't work, but if anybody prepares their taxes using TurboTax, you're using an expert system, and you bet your life it works. It makes a ton of money for everybody, people that fill it out, the people that sell it. Might not have a lot of world knowledge. Okay, so world knowledge is relevant to this recent proposal that Untitled has given. This is taken right from his paper. This is the kind of thing that machines are completely stumped by, at least at this point. There's a deictic here, that's the key, and that's the problem. So these are very different questions, right? So what's needed? A process exploiting enough background knowledge to recognize the following. A caller being successful, a phone call requires that the recipient of the call be available. So machines can't do this now, but I think this is not all that tough, probably in the foreseeable future. That will happen. Regardless, I think Winograd's suggestion is vague, so we need to to tighten it up. So let me see if I can go quickly here and get to dimension 3. So this is the one I wanted to get to. This is the one that completely paralyzes current QA systems, or for that matter, any AI system that I'm aware of. So humans have this remarkable ability to assimilate new words on the fly, and even very young kids can do this. So here's an example. If every X is a zag and all zags zig, given H does not zig, is H a zag, is H an X. So there are millions of variations of these. They traditionally are used to teach formal logic because they isolate the human's ability to work on abstract structures that have nothing to do with a particular concrete situation. And so novelty, Naveen and I claim, with John, is a dimension that you have to sort out. Does he have another example in here? Yeah, so he has two additional examples. IBM's given us the Watson system, by the way, very generous and some support. They're working on seeing whether extensions to these kind of questions would be possible, but that means going quite beyond what the technology used to produce victory in Jeopardy was. So humans can do this, machines can't. I'm not holding my breath about these so-called smart machines that are going to leave me in the dust. That's actually not going to happen. I don't think we'll ever have machines as smart as humans. I know that's probably anathema given the context, but we don't have machines that can carry out a conversation with a toddler after spending billions of dollars, and the value of a machine able to do it is enormous. So if we could do it, we'd do it, and we don't seem to be able to ever make any progress in these particular problems. So I'm going to skip this. I think I'll just go to the first. What's he got for his? This is no big. Hardness. Okay, that's the fourth dimension. I'll just go to our first theorem, which, as I said, is itself not exactly exciting. So the first cluster of theorems about questions in a QA context for us is based on our own approach to natural language processing. So they're all, as most theorems are, they're all conditional in form, but we build in our own methodology and an affirmation thereof into the hypotheses of the theorem. Okay, so we're working on subjunctive questions. This is a linguist categorization, not a logician. So in the linguist sense, a subjunctive conditional would be something like, if I were to drink 7 beers in 5 minutes, then I would be intoxicated. So it would be very nice to be able to ask machines these kinds of questions. I mentioned Bloomberg, very interested in it in their case because of the financial value of being able to ask questions like, if I were to carry out this investment, I would have a certain return. Now we have a specific way of understanding subjunctive conditionals, and for that matter, conditionals. But when we follow our approach, we get the result that on this particular dimension, the subjunctive version of Q is as high as the indicative version of Q. And so I promised that this was boring, and I think I probably delivered on that. I'd like to tell you that there are a bunch of theorems of interest, but I'm having my doubts about the level of interest that other people will have in this direction, but we'll pursue it. Now there's a proof sketch, which I'm going to, unsurprisingly for anybody who knows me, it's all based on formal logic. So we'll skip this. This is the traditional conditional in logic for for a conditional that's not an indicative conditional, say a material conditional. So here's the subjunctive one. If this were to happen, then this would happen. And so what we need, and what we have at this point, is a way to systematically introduce subjunctive conditionals and a way to eliminate subjunctive conditionals. And put intuitively, the basic idea that we pursue is that you're allowed to introduce a subjunctive conditional when relative to an agent and the agent's mind, you can deduce that if there's a hypothesis about a world line, not a possible world, but a world line in which phi holds, you can prove that psi holds as well. So that's basically how introduction works. And this machinery supports the construction of the first confessively boring theorem. And then we have an elimination rule. Now, extensions, I do want to mention this in the paper. It's very short. We only mention justifications very quickly. You know, in the Jeopardy competition, there was no need for a justification. In the real world deploying this technology, there would almost invariably be, if it's high stakes, a request for a justification as to why the machine has produced the answer it's produced. And machines are really bad at doing that. Watson was not able to do that, and I'm not sure, looking at the underlying logico-mathematics, how it would do it, since it's basically parallelized logistic regression. I don't know how it could do it, but I think that's an important dimension, important part of the formalization to have for measuring the relative effectiveness of QA systems. When people say they've got a good one, we can use these metrics. So, let's see. If we don't have justifications also, we could just have serendipity, and machines would get credit for something that really isn't necessarily that smart in terms of a response. The justification criterion, I don't think this is, I think this needs to be improved, but this is the basic criterion that's in the paper. There might not have to be an outright proof, but there should at least be an argument classically for a justification. I think ultimately, if the machine is going to get a lot of credit. And let's get this. So finally, I'm not sure exactly what he wanted me to do with this, but it's not clear that in order to score well on the metrics we've set up for QA, the system has to understand anything, let alone the humans with whom it's interacting. And in order to do that, then we think you need a very robust intentional logic, and we have tried to defend that in various publications. And I think that's the concluding slide. There's this one is three papers there that relate to our own work on sort of how to do QA type work and what the underlying formalisms would have to be. So, I think that's got to be under 15. 14 minutes, I think. 14, thanks.